Hello everybody and welcome back. We're looking at question number 23 on the 2003 Cayley competition. Okay? If you haven't gotten a copy of this competition already, by all means click the link in the description. You can get it and several other of the University of Waterloo math contests to have a try. Okay, but that said, let's take a look at question 23. A pyramid has a square base which has an area of 1,440 centimeters squared. So square base, what would the side length be? The 144 tells me there should be a factor of 12 there. And then I guess we have a square root of 10 as well. So 12 root 10 is looking like a length of the square base there. Okay. So we got square base. Each of the pyramid's triangular faces is identical and has an area of 840 centimeters squared. And so these triangular faces, they're going to have a base, which will be one of the sides of the square base, and a height. So that might come into play when we try and work out this area and some other lengths. The height of the pyramid in centimeters is... Okay. So it's a three-dimensional geometry problem, and those, I admit, are tricky. They really can be. So I do encourage people, if you can, bring props. I mean, you can probably find at a craft store a square-based pyramid and a cube and a rectangular and a circle, just little wooden ones that you can bring out and say, aha, now I can sort of visualize what's going on. And if it's wood, you can mark it up with pencil too. So that's something I encourage if your proctor will allow that. Even to work on these things at home, just so you get a better idea and can more manipulate them as you want, and then maybe on the contest, even if you don't have the prop, you still are used to handling it and maybe can think about it better. Okay, I'm going to draw a picture. Okay, probably going to draw a couple pictures because I think I see how to go for this one. We'll skip a page here because I want a lot of space. So, here's sort of my square-based pyramid. We got the dots to signify that it's behind the big thing. So we have our base and the triangular faces, and we want the height. And the height drops a nice little perpendicular, and that's what we're trying to figure out. Suppose we look at it from the side. If we just look at it, sort of dead on from the side, our base sort of goes away. It becomes just this line, which I've already said I'm pretty sure is 12 root 10, but we'll get to that in a moment. But if we just look at it from the side, we sort of have our altitude as a right angle here. Okay. Now what we can do is we can say, well, hey, I've got sort of a right angle triangle here. If I knew this length, which happens to be, say, this length here, and I knew this length, which happens to be this length here, we got ourselves a right-angled triangle. Okay? Now this green one is just going to be half of the side length of the square, so I believe it should be 6 root 10. And then if we can get this blue one, which happens to be the altitude of one of the triangular faces. And the altitude of one of the triangular faces, well, hey, if we know the base, that's a height for one of the triangular faces, and we know the area of those faces. So things are sort of starting to come together. So first let me note that, so let, I don't know, B equal side length of base. So since it's a square, we know that b squared, and we're told in the question that it's 1,440. That means b has got to be the square root of 1,440. But that's 144 times 10. One of the nice things about square roots is if you have a multiplication, it distributes over multiplication. And square root of 144, why, that is 12. So we get 12 root 10. The root 10, it won't go down any further. I recommend leaving it exactly like this rather than grabbing your calculator and trying to work it out. It'll probably be 36 or 37 or something like that. Just because we're going to be doing more calculations with them. And you can have decimals, sure, but the minute you cut it off at 2 decimal places, 4 decimal places, you are rounding. And if you introduce rounding errors early on in a problem that has a lot of calculation, you can find that you're actually pretty far away from your answer at the end. Okay? So, that said, we're going to leave it as 12 root 10. So that is, in fact, the base side length there. Now, if we just look at one of these side triangles, it's got a base of 12 root 10, and it's got our blue altitude, which forms the hypotenuse of this triangle. That's going to really help us. We know the green one's going to be 6 root 10. If we just knew the blue one. So let A equal altitude or height of triangular face. Okay, and that's the blue line lies along the face, so it really is the height there. So we know that the area, which I believe is 840, let's just double check, 840, that's the area of each of the identical triangular faces. That should be 1/2 base times height. Well, the base is B, and the height is this altitude. So that should be 1/2 12 root 10A. And we're going to flip over to the next page, but we're just going to rearrange this. So 840 is 1/2 of 12 root 10 is 6 root 10 times A. Let's divide by 6 on both sides. What's 84 divided by 6? It's 14, so we're going to get 140. And we got rid of the 6 there. Root 10A. Well, 140 is 14 times 10. And that's 14 times root 10 root 10. That's what square root does. Square root 10a, and we cancel out one of these root 10s. A should be 14 root 10. That's what we're looking at for the height of one of these triangles. Okay? So now, what's the thing that we want? We want that red line that was the height of the pyramid. And we had made a right angle triangle with 6 root 10 on the bottom. And we had that blue line that was the altitude of the triangular faces, and that we have just worked out is 14 root 10. We're going to call this H. We're going to say that H equal the height of the pyramid. Okay. Well, heights make a right angle with the base, so we're looking at a right angle triangle. So if we want to, we can say by Pythagoras, although since this isn't a written contest, we don't need to say what we're doing. But by Pythagoras' theorem, it's one of those basic theorems that you should know. 6 root 10 squared plus h squared is 14 root 10 squared. Okay? Well, let's work this out. 6 squared is 36 times root 10 squared. The root and the 2, they're going to cancel out, so we'll just get 36 times 10 plus h squared, and then that's 196 times 10, so 1,960. So if I just want h squared by itself, we do 1960 minus 360, and we should get 1,600. Square rooting both sides, we'll get an answer of 40. Okay, so the height of the square base pyramid is 40. Height of our pyramid is B, 40. There it is. Okay, that does it for question number 23. In the next video, we're going to go through 24, and then we'll wrap up the contest in the video after that with question number 25. So thank you guys for watching, and I'll see you for those 2 videos in just a bit.